An AI-generated autofix was meant to clean up a workflow. Instead, it removed a security boundary. 5 days later, Wiz says its red agent found the flaw, adapted when its first attempt failed, and reached credentials for Snowflake's internal Jira. This is not a story about an evil chatbot. It is a story about one untrusted issue title, one privileged automation workflow, and a code review that missed how those pieces connected. Here is the entire mental model. Someone opens an issue in a public repository. GitHub Actions receives the issue event. A workflow builds and runs a shell script. That workflow also holds a credential used to create an internal Jira ticket. If attacker-controlled text becomes part of the generated script, the issue author is no longer just submitting data. Their text can influence code running next to the credential. That is the dangerous bridge. The public repository record shows pull request 1218 merged on June 18th with a Copilot Autofix co-author marker. Remediation pull request 1402 merged on June 23rd. Wiz says red agent discovered and responsibly disclosed the flaw that same day, and Snowflake rotated the Jira token on June 24th. The internal access and autonomous exploitation details come from Wiz Research. Snowflake said it found no evidence of unauthorized access and remediated immediately. The vulnerable pattern inserted the issue title directly into a run block. GitHub evaluates expressions before the runner executes the temporary shell script. So special characters in an untrusted title can change the script itself. Trying to quote the value later inside that same script is fragile because the data-to-code conversion has already happened. GitHub's own security guidance names issue titles as potentially untrusted input and recommends keeping them out of generated inline scripts. The workflow appeared to have a guardrail, but it checked a pull request field while the trigger was an issue event. That field was not present in this event shape, so the intended check did not restrict the job as reviewers may have assumed. This is a subtle but important lesson. Security conditions must be tested against the exact event that triggers the workflow. A convincing-looking condition is not evidence that the path is closed. Before the change, the workflow moved the issue title through an environment variable and passed it into a structured JSON builder. The autofix replaced that approach with direct workflow expression interpolation inside the shell block. The new code may have looked shorter, but it erased historical security context. That is why AI-generated diffs need more than syntax review. Reviewers must ask which trust boundary existed before and whether the edit preserves it. For the CipherVibe lab, we use a fictional Northstar connector repository. A local JSON object contains an issue title with a harmless, untrusted marker. The simulator compares two workflow designs. It never invokes a shell, never creates a real credential, and never sends a network request. The unsafe design is stopped at policy evaluation. The goal is to make the boundary visible without teaching or replaying an exploit against a real platform. In the unsafe model, the workflow template combines instructions and the issue title before execution. Our policy engine detects that untrusted event data has reached a script generation sink. It records a boundary violation and stops. Notice what we are testing, not whether a particular payload works, but whether public data is allowed to influence executable text at all. That invariant is easier to review, automate, and enforce across many workflows. In the safer model, the untrusted title stays in a data channel. A dedicated action or program receives it as an argument and builds the request with a JSON library. If a shell is unavoidable, pass the value through an environment variable and quote the shell variable, but remember that a purpose-built action or SDK is clearer. Then limit the credentials so this workflow can create only the ticket it needs, not browse unrelated internal projects. Wiz says red agent did more than flag a suspicious line. After an initial syntax error, it adjusted its approach, obtained an out-of-band callback, and validated access to the internal Jira service without human intervention. We cannot independently verify that internal execution from the public repository alone, so keep the attribution attached. The broader point is still important. AI can now generate risky code and help find exploitable paths. Governance must cover both uses. Think of continuous integration as an airport transfer bus. The public issue is a passenger at the curb. The runner is the bus, and the stored Jira credential is the badge that opens an employee entrance. If the bus accepts instructions from any passenger, the problem is not only the passenger, it is the route, the badge, and the door. Reduce risk at every layer. Trusted triggers, isolated jobs, narrow permissions, short-lived credentials, and downstream authorization. When reviewing an AI-authored workflow diff, start with the trigger. List every field an outsider can control. Trace those values into shell blocks, templates, expressions, API calls, file paths, and logs. Then inventory every token, secret, network route, and downstream permission available to that job. Finally, compare the diff with the previous version. A deleted environment boundary or structured serializer may be the most security-relevant line in the entire change. Prevention means keeping untrusted values out of generated scripts and scanning workflow files as production code. Containment means separate jobs, minimal token permissions, narrow Jira roles, and short-lived credentials where possible. Detection means audit logs, egress visibility, and alerts when a workflow identity reads projects it normally never touches. Add regression tests using realistic event shapes, because a condition tested only with pull request data will not prove safety for an issue event. The lesson is simple. Public event data must remain data. A guardrail must be tested with the exact event that reaches it. CI credentials should be scoped as if the runner might be compromised. And every AI-generated diff needs a reviewer who understands the trust boundary it changes. Snowflake patched the workflow the day was disclosed it and rotated the token the next day. Now inspect one privileged workflow in your own environment and trace one untrusted field from trigger to sync.